Hi. In the last video, we finished discussing contract curve. And this is the last tool that we need to prove Rybczyński proposition within the neoclassical model of trade, within the neoclassical model framework. Okay, now let's put all the things that we've learned thus far together and actually show that within this model this proposition actually works. Okay, so what do we start with? Look, we treat now that prices of manufacturers and prices of food are given. But look, using factor price equalization proposition, we know that if we have prices of goods, we will be able to find wage and rent. They can be calculated, they can be found. Now, knowing W and R, so wage and rent, we also know that we can find each company can find a capital to labor ratio that is optimal for them, so it minimizes the cost. So with prices known, rewards to the factors are known, and with rewards factor to the factors known, K, M. So ratio, optimal ratio of capital to labor in manufacturing and capital to labor ratio in food industry. Now, thing is that if we know those and if we combine known capital to labor ratios in two sectors with the assumption of full employment, we can actually find a point at contract curve that will show us the distribution of labor and capital between manufacturing and food industry. Look, again, I started by drawing this because otherwise, graphically, it would be extremely hard to do as I'm not a robot. So, look, knowing this, we will know, of course, knowing this and having the assumption of full employment, we will know distribution of labor and capital between these two sectors. And look, if we know the distribution of capital and labor in between two sectors, so we are able to locate a point on a contract curve, we will find level of production of manufacturers and food. Okay, so I already put this on the graph. What are we missing? What are we missing actually here are those ratios. Well, those ratios here can be graphed very easily. Because if I'm gonna put a line coming from the origin and going through, perfectly straight line of course, going through this point, it's not going through this point by accident. Look, actually what I should do is to draw these two lines at the end. But of course, I'm doing it now because it's easier to, otherwise I would have a lot of problems drawn. But look, no, those isoquants come solely from technical coefficients. So they depend on capital intensity in the two sectors, right? It's like we would be able to draw an entire map of isoplans. We would get this line. But now, if I know prices, I can calculate rewards to the factors of production. Knowing those, I can calculate the ratios, because those ratios are given over here. And of course, by the same token, I can find the ratio. And I hope I'm gonna do it properly, because this is very hard. We are assuming that this line is perfectly straight. Yes. Now, this ratio, we can end with the angle over here, because remember, it's upside down. And look, those two will actually, at their intersect, show us the point at which the economy is. And look, this point is telling us everything that we wanted to know. Look, from this point, we are getting that this much labor is employed in manufacturing. Well, this much in food industry. We have the same thing here. We know that this much capital is employed in manufacturing, while this much in food. Now, but look, this is not the end. We came from here to here to here to here. But look, if we know the point at which those two lines intersect, we can find the two isopoints. You see, as I told you, this is the right moment at which I should draw the isopoints, but I was afraid. I tried a couple times to do it, and I always get it, in a slightly wrong place. So this is why this is actually the appropriate moment for me to draw the two isoplans, and those two isoplans are telling us what is the level of production of manufacturing and food. Okay, so look, we've established quite a lot, but still we do not have Rybczyński proposition anywhere over here, right? Because labor and capital here are constant. Okay, so now this is exactly what we are gonna do. Now, in the next graph, I'm just going to use only those two lines, because knowing those two lines is enough to find everything else, and because it's enough to find everything else, we know that, that it is sufficient to know just two of them. Okay, now give me a second, and let's start with a new graph. Okay, so look, again, this is going to be an Edgeworth box. And in this Edgeworth box, let's say that again we've got some, this is our line associated with capital 2, labor manufacturing ratio. Of course, here we've got this O, M, here we've got O, F, here is K, here is some L. Let's say here we've got K, here we've got some L0, because the amount of labor in our economy will be increased. Okay, and now the second line, of course, over here, given by the capital to labor ratio in food industry, they are giving us equilibrium. They are giving us equilibrium that gives us, of course, distribution of labor and capital as well as level of production of manufacturers and food, right? All we need to do is to draw two isoplans to get it. Now, what would happen here if, let's just say, our country opened borders and now we have an inflow of workers from other countries? How things would change over here? Well, now we would have more labor, but we would have the same capital. So look, now the origin for food industry is moved over here. Let's denote it with a prime. Okay, but we've got more labor, but prices of manufacturers and food are the same, which means that wages and rents are the same, which means that optimal ratios are the same. So, all I gotta do to find new distribution of labor and capital and manufacturing and level of production of manufacturers and food is to draw a new line from the origin. And of course, this line needs to go through the same angle. I don't think I'll be able to do it perfectly, but I think it's good enough. Of course, we are imagining these two lines are perfectly parallel. And still, we've got the same angle here, okay? Over L, right? So, what we get over here is the new equilibrium associated with the higher level of labor in the economy. But look what is happening over here. It turns out that we've got more labor, and what is it? So what has happened? Look now, before, the amount of labor used in production of manufacturers was this much. But now, it's just this much. So now look, actually, now, manufacturing sector is using more labor. Then, we also see that at the beginning, manufacturing was using this much capital. But now, it is using this much capital. What does it mean? If it uses less labor and less capital, while have the same optimal capital to labor ratio, it means that the level of production of manufacturers has gone down. What about food? The opposite. Look, before manufacturing was using this much capital, now it uses this much capital. Before it was using this much labor. Now it is using this much labor, which again means that level of production of food has increased. So look, what it actually, this is the essence of Rybczyński proposition. If the amount of one factor of production is increasing, actually in the long run equilibrium, the economy, and this factor of production is labor, the economy will produce more food, but actually it will also use more capital and more labor. On the other hand, in case of manufacturing, it will use less labor and less capital. Okay, and as you see, this is the key insight of the Rybczyński proposition, and of course it works. Over here very well. Look, we could complement this graph with isoplans, but this is really unnecessary and problematic to draw properly. But of course, let me try. Hope I'm gonna get it the first time. Oh, I did. Okay. And look, we clearly see over here that the amount of manufacture at the beginning is bigger than after the increase in the increase in labor force. And the same is true over here. We could easily see that here, that at the beginning of food, we're producing less food. Now we are producing more food. Okay, now the last thing I wanted to show you about the distribution of labor and capital is the relationship between the shares. But this one we need to do mathematically. But of course, this derivation is going to be extremely easy. Okay, I hope you like the graph because it came out way better than I expected, even when I was drawing it in my notebook. Okay, so let's check out one more thing. Let's just say that we have some amount of capital and some amount of labor in the economy, and this is, so here we've got the capital to labor ratio. Now, using the assumption of full employment, we get that this is equal to Km over L plus Kf over L, right? Because the capital can be used either in manufacturing or in the food industry. Now, I can rewrite those very easily like that. Okay, right? What do we have over here? Look, this is a share of labor used in manufacturing in total labor. This is the share of labor in food as a percentage of the. This is share of labor in food industry in total labor, right? Now, what do we have here? Well, this is capital to labor ratio in manufacturing and capital to labor ratio in food industry. Okay, and look, because those are shares, they have a very specific property, right? If I would add those two, they would end up to 1. So let me rewrite K over L a little bit differently as lambda m, so share of a labor in manufacturing times Km over Lm plus 1 minus lambda m, right? We need to sum up to 1. So this is the share of labor in manufacturing. This is the share of labor in food industry, which is 1 minus, remember, those are like percentages. So here we have KF, those are not like percent, those are exactly percentages, I'm sorry. It is very late and I just came out of COVID, so I'm not bringing my best game. Okay, so this is something, well, look, this is tautological. We haven't added anything. We just rewritten what we had in a slightly different way. Now, let's, for now we just concentrated on this. But look, here we have capital to labor ratios in manufacturing and food industry. But before, we found that those optimal ratios, right? For manufacturing industry, it's wage over rent, yeah, and in food industry, it's this much. Okay, so if we know those optimal ratios, let's substitute them over there, and let's see what we're gonna get. Longer joke. Okay, so we've got this is alpha lambda m and alpha m over 1 minus alpha m w over r plus 1 minus lambda m alpha f over 1 minus alpha f w over r. Look, the clear thing that we see even from this is that assuming full employment, if capital or labor is going away from food industry, it needs to end up in manufacturing industry. So we can treat, you see, what we've got over here is basically a weighted average. We see that K to L, so capital to labor ratio, is weighted average of the ratios of in two industry where weights are given by labor shares, right? Okay, so now what I want to do over here is to solve this equation for labor share. Can I find it? Can I find it directly? Well, I definitely can. Okay, so look, what do I want to do over here? I would definitely like to put all the expressions with alpha m on one hand side of the equation. I'm going to put it on the left hand side because this is how I like it. And everything else on the left hand side. So look, I'm going to treat this as the left hand side. So I've got here alpha m times lambda m over 1 minus alpha m w over r. Look, here I have minus, right? So what's, I can say the common part, if I multiply this, I can combine this with this. So I would have minus alpha f over 1 minus alpha f w r. But again, look, even though we are solving this only with respect to lambda m, we see that w over r are repeated. Yeah, why not take them out as well? It's lambda m w over r equals to, okay, and on the other hand side we would have k over l, and of course 1 times this expression, but with minus because we are moving it to the other hand side. Okay, and look, again, we need to multiply this, we need to calculate this out first. Of course, you could say, no, we don't need to, but we will get a nicer expression. And actually, the trick to this is very similar as with the contract curve. Because look, if I multiply this by 1 minus alpha f, I'm going to get that this is alpha m minus alpha m alpha f. Now, this times this gives me minus alpha f minus and minus plus alpha m alpha f, and divided of course by 1 minus alpha m 1 minus alpha f. Again, those two cancel each other out, so I can rewrite this expression as alpha m minus alpha f divided by 1 minus alpha m 1 minus alpha f. Okay, so look, now this is a perfect time to solve it for lambda, and if I'm going to solve it for lambda, again this is okay, so I need to multiply by reciprocal. So I'm getting out of this expression that this is going to be 1 minus alpha m times 1 minus alpha f over alpha m minus alpha f, and here k over l times divided by w over r, and here we will have minus, those two will cancel, each other out, and we will get that this is alpha, this is going to be, 1 minus alpha m over under alpha f, alpha m minus alpha f. And assuming I didn't make any mistake, which I didn't, look, this formula actually allows us to see, allows us to express the share of labor in manufacturing as a function of total capital to labor ratio in the economy and the wage rate. So knowing those two, right away we can have this shape. And look, the final thing we can do, well, we can do way more, but the final thing I wanted to show you is that knowing this, we can also find level of production. Because look, level of production capital used in production of manufactures to the power alpha m times labor in production of manufacturers times 1 minus alpha m, which we can easily transform. Which we can easily transform to Km over Lm to the power alpha m times Lm. But maybe if we know Lm, we can express it simply as a function of of labor alone. Of course we can. But first, we know that the optimal ratio is here, right? And this optimal ratio, right, is given by alpha m over 1 minus alpha m w over r to the power alpha m. And now this can be expressed as lambda m times L. So look, again, we have shown that we can find the level of production of manufacturers as long as we know a wage, rent, of course, technical coefficient, and the total amount of labor in the economy. But of course, remember that this one is determined over here. And look, in exactly the same way, we could do this for food industry, right? Because with one simple distinction, because we would have Kf alpha f L f 1 minus alpha f, which would give us Kf over Lf to the power alpha f times Lf, and here we would have alpha f 1 minus alpha f w over r alpha f 1 minus lambda m times L. Okay, and I think this is enough about the Rybczyński proposition. In the next couple of videos, we're finally gonna truly open the economy and explore Bertrand Olin proposition. Okay, see you in the next video.